Hey everyone, so this video is on graphing rational functions. This ties everything together that we've been learning. Simplifying rational functions, finding asymptotes, finding x-intercepts, y-intercepts, making a table of plot points. Graphing rational functions ties everything together. So this is a rather large video. There's about 4 examples we're going to go through. Feel free to stop the video and do it yourself before you watch me explain. Feel free to just look at the functions ahead of time and figure out which ones you want to watch. Anytime you're watching, make sure you're always taking notes. So let's get started. So in order to graph rational functions, guys, we have several things that we need to do, okay? So if you want to pause this video, write down these steps. There's a lot of information that we need to find to throw on a graph to graph a rational function. Okay, so in order to graph a rational function, first thing you need to do is factor anything that you can. Factor numerator, factor denominator. Second thing is we need to, basically these next 3 steps is find your asymptotes. Vertical, horizontal, and slant. And then also, then you'll throw those on the graph. And then you're going to, next is create a table to find any additional points. Step number 6 will make more sense when you see us start to graph these, and you'll notice I'm going to need some more points to figure out where to plot everything. 7 is finding our intercepts, and then there's a little refresh on how to find intercepts if you're not sure. Plot all the points, sketch the curves between and around the points, through the points. So here is our first example. Notice I've listed out everything that we need to find, and I would do the same too if you're on a quiz or anything. You know, as soon as it's a rational function, you need to find these things. So let's get started. First thing, factor everything we can. There's nothing for me to factor in this function. Second step is let's find our asymptotes. Vertical asymptote, we know we need to set our denominator equal to 0 and solve. When I do this, I get x equals 1. That's my vertical asymptote. Let's throw it on our graph. X equals 1. Here's my vertical asymptote. And guys, any point you forget how to find vertical any of these asymptotes, go watch the videos on the asymptotes. Horizontal asymptote. Our numerator degree is 1. Our denominator degree, that's supposed to be an m. Our denominator degree is 1, which means that we look at the leading coefficient. It's a 2 over 1, which means y equals 2 is our horizontal asymptote. So go ahead and I graph our horizontal asymptote. So you can see our framework starting to come together of our rational function here. Slant asymptote happens when the numerator degree is 1 larger than the denominator degree. There is no slant asymptotes here because our degrees are the same. Okay? Holes happen when common factors cancel. There are no common factors here, so there are no holes. Intercepts, let's go ahead and find our x-intercept. Our x-intercept is when we set our equation equal to 0. If I set my equation equal to 0, I'd multiply both sides by x minus 1, so I'd be left with 0 equals 2x. Divide both sides by 2, and I get 0 equals x, so I know my x-intercept is at 0, 0. Y-intercept, I'm going to change the color here. Y-intercept is we substitute 0 in for everything. 0 in for our x's. And we get 0. So I know my y-intercept is also the origin. Okay, notice now you can see from, I just found all the information they told me to. My asymptotes, my intercepts. I graphed it. I can't make a rational function from every piece of information that's on the graph. I need more. So that's why we need to make a table. And I need to come up with some more points. So we want to have at least 2 points on either side of our vertical asymptotes. So notice I already have 1 point, the origin, to the left of the vertical asymptote. So I'm going to pick another one. I want to know what goes on, let's say, at -1. And then I need 2 more points to the right side of the vertical asymptote. Our vertical asymptote is at 1, so let's figure out what happens at 2 and at 3. And all we do, guys, is we're going to substitute -1, 2, and 3 into our function. So I'm going to just do one of those. I'm not going to do them all. If we do -1, we would do 2 times -1 over -1 minus 1. -2 over -2 gives me 1. When you plug 2 in, you should get 4, and when you plug 3 in, you should get 3. These points, I'm going to plot them. So I'll have -1, 1, and then I'll have 2, 4, and 3, 3. Notice now I have more points that'll help me graph, and I'm going to be able to make the curves. We go along the vertical asymptote and then along the horizontal asymptotes, never touching or crossing the asymptotes. Along, through the points, and along. That's our first rational function that we graphed. Great job, guys. Let's try another one. First step, factor anything that we can. Our x plus 2 can't be factored. Our denominator can be factored. Notice when I factor it, we have a common factor. So I can cancel that out, and I'll be left with 1 over x minus 2. Okay, so our vertical asymptote, set our denominator equal to 0. And solve. There's my vertical asymptote. I could graph that right away. Horizontal asymptote, numerator degree, and it doesn't matter which one you look at. We'll look at the simplified one. Numerator degree is 0. Denominator degree is now 1. When it's bigger in the denominator, the horizontal asymptote is 0. I can plot that. Slant asymptote is when the numerator degree is 1 larger. It's not. There is a hole, right? Because we did have a factor that canceled. So that factor canceled when x was -2. So I have to figure out what point that's happening at. So I plug that -2 into my simplified function. So I have 1 over -2 minus 2 is going to be 1 over -4. So I have a hole at -2, -0.25. And we can plot that. So I'll go to -2 and -0.25. We've got a hole, and we literally graph it as a hole. Our x-intercept, we set 0 equal to y, and I'm going to get equals 1 over x minus 2. Multiply both sides by x minus 2, 0 equals 1, so I have no x-intercepts because 0 does not equal 1. Which makes sense, guys, because look at our x-axis. There's an asymptote there, so nothing can touch that x-axis. Our y-intercept, we set x to 0. And so I'm going to get 0, -0.5. And I'm going to put that point in here, very small. And now we're going to look for some extra points. I've got 2 points already on the left side of my asymptote here. So I'm able to graph this through our points along our asymptotes. I don't know what's going on the right side of the graph, so I need 2 more points on the right side of the graph. Let's pick, well, we know it's 1, 2, let's pick 3 and 4. Again, we're going to substitute them into our simplified function. I'll just do 1. 1 over 3 minus 2, 1 over 1 equals 1. 1, and then 4 is going to be a half. I'm going to take those points and plot them on the graph. So I've got 3, 1, and 4, a half. And that helps me graph this function. And there we go. Okay, let's check out example number 3, and then this is my last one. Okay, first thing we do is we factor anything that I can. So we're going to factor our numerator here, x plus 4 times x minus 3. Right? Yep. And then x squared minus 2 factors to x plus 2 and x minus 2. Nothing cancels. So as soon as I see nothing cancels, I know I've got no holes. Okay? Vertical asymptotes, I set my denominators equal to 0. So I get x equals -2 is 1. Notice I have to set my other denominator equal to 0, my other factor, and I get x equals 2. So I've got 2, let's graph them. -2, and then +2. Horizontal asymptote, my numerator degree is 2, my denominator degree is 2. So I look at the coefficients, which is a 1/1, so my horizontal asymptote is at 1. Notice all of our horizontal asymptotes are graphed with dotted lines. Slant asymptote, numerator degree and denominator degree are the same, so there are no slant asymptotes. X-intercept, we are going to set our function equal to 0. Denominator will cancel out. So I just am solving this. I've got it, when I solve that, I've got an x-intercept at -4 and +3. So I could plot those points. That's helpful. -4 and +3. And let's see, y-intercept, I'm going to set all the x's to 0. So I've got y equals 4, because that's going to be 0 plus 4 is 4 times -3 over 2 times -2. So that gives me -12 over -4. Gives me a y-intercept at 0, 3. I can plot that. So guys, notice this gives me a lot of information, but I still need extra points. I need 2 points in each region of the vertical asymptotes. So what should we pick? To the left of this vertical asymptote, I have one. I know I've got a point at -4. Let's do another one. Let's do another one at -3, right? I want to figure out what happens there. I have no idea what's going on in the middle region here. So let's get 3 points in the middle region here. I'm going to go 1 and then -1. And then I need one more point to the right of that asymptote, let's say 4. Okay, and we're going to substitute right into this function, guys. I'm not going to show you that work, but we're going to get -1.2, 4 for -1, 3.3 repeating for 1, and 0.6 repeating for 4. And then I can go ahead and plot those points. I've got -3, -1.2, 1, 3.3, -1, 4, and 4, 0.6. And that gives us a lot of information. We can now connect these points along the asymptotes. And so this is the first time we are graphing with 2 vertical asymptotes. Notice the behavior between the vertical asymptotes there. Okay, and there's 3 parts to this curve. Great job, guys. That is some 3 examples on how to graph rational functions, putting together everything that we've learned. Send any questions my way. Great job.